Okay, hi everybody. So today, this lecture or this video is going to talk about the results section. And so if you pull up the results section slides, I'll tell you when I'm going from slide to slide, just like the last videos, just to um, help you, you know, progress with me, so you know what slide I'm talking about. Um, So going on to slide 2, this is just a quick introduction. So when we talk about the results section, what we're talking about is statistics, right? And so this part of the paper essentially gives you the numerical foundation for your hypotheses and for your outcomes. However, we do want to make sure that we're kind of cautious when interpreting statistics. There are many ways that you can be tricky with numbers. If you're an honest researcher and an honest person, you won't have this problem, but many people are not so honest, especially when they have motivations to present certain numbers as facts. And so the British Prime Minister Benjamin Disraeli once said, there are three kind of lies, damn lies, and statistics, which is really funny but also true because there really are ways where you can make stats say whatever it is that you want them to say. And so we just want to keep that in mind. So just to illustrate that in a minute, we'll go over that. And so the results section will have two different types of statistics. The first one is descriptive statistics, which just simply describe the findings, hence why they're called descriptive. And what we're talking about is means and standard deviations for our purposes. We're also going to have inferential statistics, which allow us to make inferences about the differences between our conditions. And so we call them inferential because we're making inferences. The numbers don't tell us anything. They're just numbers, right? They just tell us the means and the standard deviations, and the calculation can tell you if those differences are significantly different statistically based on some alpha, right? If you remember from stats, it's just whether you set your alpha to 5% or 95% or 1% or 99%, whatever it is. And so if your alpha is 0.05, you're saying that you're only allowing for a 5% chance that the results are due to chance, or the differences between the results are due to chance. And so you're making inferences based on that alpha, okay? But first, so in line with the other slide and then this, I want to make sure that we have an example to illustrate why we need inferential statistics and not necessarily just to rely on means. And so example, let's say I were to give you this, in the next, I'm on slide 4, I apologize, I'm on slide 4. So in this example, you have two groups, either men or women, and I'm just measuring their weights. This is a very simple t-test. And from this sample, I have that the average weight of men is 160 pounds and the average weight of women is 175 pounds. So given that I sampled 6 men and 6 women from this data, can I confidently say that on average women weigh more than men? Even if I run a t-test and show that, yes, this is statistically significant, right? Why might this be a problem, right? And so in slide 5, it kind of reveals that if I looked at each individual subject and I took the men and I look at their weights, I may realize that I have 4 men that are below what we would consider average male weight, right? So if you find a male that's 125 pounds, that is really rather small for men. You also have an outlier for women, both on the higher end and the lower end. So you have a woman that weighs 100 pounds, which is way below the average weight of a woman. But you also have a woman that is a complete outlier on the other end of the spectrum, that's 350 pounds, which is a morbidly obese weight. And so any one participant, especially on such a low end, when you only have 6 of each, may be driving the average up or down. And so you need your standard deviation that tells you how varied the sample is, and you also need to consider sample size in order to determine whether your means are essentially representative. And your inferential statistic will let you know whether the standard deviation is way too high. So if you ever have a standard deviation that's higher than the mean, that's usually an indication of some sort of problem. That means your data is way too varied in order to make a reliable mean. Or if there's not enough variance, if your standard deviation is 0 or close to 0, that might also be a problem. And so inferential statistics captures all of that and takes that into account. All right, so moving on to slide 6. Now let's get back to our results. Going to slide 7. I uploaded, along with the slides and this video link, the actual output. So your homework was to give me your data analysis. Not everybody did the correct data analysis if you handed it in yet, and that's fine. I really wanted you to practice playing with these numbers, but I provided you with the actual output, and what I did was I took the main parts of the output so it doesn't get too confusing, and then I pasted it into Word so that you have the main parts. And so here in this slide 7, you have the means and standard deviations for all 4 conditions. So assistant no blazer, CEO no blazer, assistant blazer, and CEO blazer. And we have the means and standard deviations. Please note that you will need to make a table with this data. Actually, it'll look very similar to this, but you will follow APA style. If you're not sure how to do that, please see the APA manual. So let's really briefly go over what these words mean. So again, we all know what a mean is, or we should, right? It's the average of all the scores. And what you do is you just add up the sum of all the scores and divide by the total number of participants, or in this case, the number of n. Standard deviation simply tells us the average distance the scores are from that mean. The greater the standard deviation, the more varied the scores. The lower the standard deviation, the less varied the scores. So it's how much do the scores vary from that mean. And what we did was, as we discussed in the data analysis lecture, is an ANOVA. So we specifically did a 2x2, which is a two-way ANOVA, a 2x2 repeated measures ANOVA. Repeated measures because this was a within subjects design. But an ANOVA essentially is just an analysis of variance. And so it allows you to know, or it tells you, if there is an overall significant difference between a group or a set of groups. And then when we talk about significant or what's not significant, what we're talking about is the alpha, right? So an alpha or p-value of less than 0.05 or 0.05 or less allows us to make the claim that we have 95% probability that this result is not due to chance. We could get into the conversation of p-hacking and what does a p-value really mean and when should we use it, but that's a statistical conversation that you can have. We can have it at a different time. It's beyond the scope of this class. So moving on to slide 9, what we did was a two-way ANOVA, specifically again a 2x2 repeated measures ANOVA, and essentially the two-way ANOVA compares the mean differences between groups that have been split onto 2 independent variables, what we call factors. An ANOVA is sometimes called a factorial design simply because you have 2 different factors. And so the primary purpose of a two-way ANOVA is essentially to understand if there's some sort of interaction between these 2 independent variables on the dependent variable. An ANOVA, all ANOVAs, regardless of what it is, are reported using an F value in this type of format. So you have the F, you literally say F, and then in parentheses right after, you have your 2 degrees of freedom, then your F value, and then your P value. And again, a P value lower than 0.05 means that that ANOVA was significant, and that there was either a significant main effect or a significant interaction. So what does our ANOVA show? Below on the table, I'm on slide 10, below on the table you'll see the test within subjects effects, and I highlighted in red all the areas that we're going to discuss that tell us three major pieces of information from our results. The three pieces of information is whether there was a main effect for attire, a main effect for occupation, and then interaction between attire and occupation on overall competence. And so if you look at the table below and you go to attire, that red bolded line of attire, you can see that we have an F value of 62.64, and the significance value is 0, right? 0.000, which is amazing. That pretty much means that this difference is very unlikely to be due to chance. And so when we report it the way I typed it out on top, which is F, in parentheses, you have the 2 degrees of freedom, 1, which is your actual degree of freedom of your condition. We have 2 conditions, and so your degree of freedom is 1, which is total number of conditions minus 1, so 2 minus 1 is 1. And then 63 is your error degrees of freedom, because we have 64 data points because of within subjects design. We have 16 and 4 groups, that's 64. And so you have 1 and 63 as your 2 degrees of freedom, and then the F value of 62.64, and then the P value is reported as P less than 0.001. So when you have a degree of freedom of, when you have a significance value of 0.000, you don't say P equals 0. What you do say is that P is less than 0.001, which is the lowest P that you can get. Then if you go to the second bolded highlighted red line, it'll read occupation. So this is, do we have a main effect for occupation? And indeed we do. We have an F value of 27.12 and also a P value of 0.000, and I reported it as F163 equals 27.12, P less than 0.001. So it is a significant main effect for occupation. And then finally you have the interaction term. So this asks whether we have an interaction between attire and occupation on the dependent measure on overall competence. And we do not have a significant difference. So you'll see that the p-value is way above 0.05, it's 0.247, and the f-value is really small, meaning the difference is really small, of 1.13, really 1.37. I should fix that. But what it really means is that it's not significant. So this is not a significant interaction between these two variables with our data. And so this is just an example of reporting a 2x2 ANOVA. I made up a very silly example using pandas that you can read, but it essentially kind of shows you the gist of how you would report it, what your results section may look like. It doesn't have to be that complicated, but you essentially start with the purpose of the study, what did you hypothesize, how did you test it, meaning an ANOVA, not methods. And then what analysis did you run, and then you report the main effect for attire, the main effect for occupation, and then the interaction, and you qualify it with the means and standard deviation. So please take your time reading the slide on slide 11, which gives you this example of how to report a 2x2 ANOVA. I also highly recommend using the sample papers that I submitted that I posted on Canvas as an example of how to post your results section. With regard to APA style, the word results is just simply bolded and centered, just like the method title, and it immediately follows the method section. So the sentence after your method section, you'll have the word results, bolded, centered, and then you write your actual result body right below that. And so I want you to note, however, that the purpose of the results section is to present the statistics of your data, not to interpret what that data means. The data's interpretation is what goes in the discussion section, okay? So you can restate your hypotheses, but don't discuss whether the hypothesis was supported or not. That, again, belongs in the discussion section. You will also, for this section, need to make a figure. I already told you that you have to make a table using APA style, and that's much easier And you can follow very simple steps. Making a figure is a little more difficult, but so I'll just walk you through it. So you're going to have to make a bar chart essentially showing the means for each list. You can also include the standard deviation. So in my example, I included the standard deviation to show you what it may look like. But you can just create a bar graph with only the means. You don't have to have the standard deviation if you don't want to. So the easiest way to do this is with Excel. By the way, I'm on slide 13. I apologize. So the easiest way to do this is with Excel. The instructions are really simple. So open Excel and then type in the data like so. So if you go to slide 14, I showed you how I typed in the data in my Excel file. So I have the mean and standard deviation title on the left. Again, if you don't include the standard deviation, that's fine. You could just do the means row. And then column B, C, D, and E are the 4 conditions that we have. And what you're going to do is go to insert on the top taskbar, and then it'll pop up like a bunch of things that you can insert. And if you scroll to the left, you'll see immediately to the right of recommended charts. Click on column because we're going to make a bar graph, okay? And the bar graph, I'm on slide 15, will look something like this. So it may have the y-axis and the x-axis labeled. It may not. It may have a chart title, but unlikely. It'll say means and standard deviation. But you will essentially have to go in and label both the vertical and horizontal axes. So the vertical axes can be labeled, for example, overall competence. The horizontal axis can be labeled condition. And essentially, once you're done editing this graph, you're going to click on it, copy, and then paste it into a Word document, which will be your graph. I'm on slide 16. So for your assignment, you will need to, in your results section, also reference both the figure and the table. So you can say, as shown in figure 1 indicates, figure 1 illustrates. The actual figure itself does not show up in the body of the results section. It actually comes at the end of the paper on its own page, but you do reference the figure and the table in the results section. Because again, APA style likes to make it confusing. Not much we can do, okay? I'm on slide 17. So the figure itself needs to be centered. You have to have descriptions for both the x and the y axis, and you must have a unit of measurement, right? So you must have numbers that show up on either axes. You must also have, on slide 18, you must also have a figure caption. And essentially, a figure caption will be where you write figure 1, followed by a period, and then you're going to write a description of that figure. Why? Because you can't make the assumption that just because you made a figure that the reader knows how to read it appropriately. And so you want to make it quick and easy. An example will be on slide 19, where it shows both the figure and the figure caption. So notice that the x and the y axis are labeled, the conditions are clearly defined, the measurement is clearly defined, and then the figure 1 caption just describes what it is, right? The reaction times to the numerical Shroup conditions as a measure of congruency, right? And so it just allows the reader to know what it is that this graph is showing you. I'm on slide 20, so it's important to note that it's you have to have a figure caption that is informative. So if you just write fixation duration, that's not enough information for the reader. So you have to think about what would the reader want to read in order to be able to glance at this figure and really quickly understand what it's saying, right? You don't want them to look at the figure and be like, wait, what is it talking about, right? So you want enough description where the reader can see your figure, read the caption, and be like, oh, okay. And it's usually about a sentence, max 2. If it's more than 2 sentences, you're over-explaining it, okay? So make sure that your figure caption has enough explanatory power to make the figure understandable. On slide 21, we're talking about the table. So again, you will need to create a table where you just report the means and standard deviation for each condition. This will also be on its own page, and the word table 1 will be at the top of your page. The title of that table will be in italics, and then the table will go right below. If you're having any issues, please see the APA manual. It's really easy to create a table in Excel, and it's really a simple, ugly table because APA style, again, likes it super boring. And slide 22 is just showing you what the placement order of all these things, because it kind of gets a little confusing at this point, so I'd like to remind students. So the title page is its own page. The abstract, which we haven't written yet, so don't worry about it, will be its own page. And then the introduction, method, the results, and the discussion all flow from one to the other. And then you have the reference section, which we'll do later on, which will also be a separate page. The figure then has its own page, and then the table will have its own page. So when you submit your results section, I want you to submit the results section on its own, but I also want you to then submit the figure and the table as the same document, but on separate pages. Okay, so that way it's APA style. And that's it. So that's all for the results section. It's really quick and easy. It sounds scary, but if you understand what the numbers are, if you did the data analysis, it shouldn't be too bad. Please let me know if you have any questions. I will be available.